machine can be made of many parts, each working together to achieve the same goal. The best machines are designed with purpose and assembled with thought. However, even the best, biggest, most organized, well-oiled machines can be brought down by the smallest of wrenches in the gears, a pebble in a fan. Rice's cereal dispensers are that wrench, that pebble, in the great machine of Rice Dining Services. I'm sure you've experienced it yourself. Walk up to one of the cereal dispensers in a servery on campus, Nature Valley granola, perhaps, or Cinnamon Toast Crunch, and pull the lever down and a few grains fall into your bowl, and then nothing. You pump the lever in desperation and maybe coax out a few more, but your bowl remains hopelessly unfilled. Maybe you punch the dispenser hoping to joss the cereal free, or pick up the knife left for students like you next to the dispenser and scrape the cereal from its depths. Or maybe, pressed for time or annoyed by the effort, you leave with a bowl part full, defeated. This phenomenon is a function of the design of the valve-like mechanism which controls the outflow of the cereal. When the mechanism's lever is actuated manually by the user, the cereal accelerates downward through the outlet nozzle due to the pull of gravity. For finer-grained cereals, this mechanism poses no problem. But for irregular or large-grain cereals, however, it becomes increasingly difficult to find a limiting maximum valve diameter which prevents obstruction while still controlling the magnitude of flow to a manageable rate when no obstruction exists. The instance of a constructed dispenser poses several challenges to the rice dining community. Firstly, a destruction leads to an increase in food waste and decrease in sanitary food health practices. The current workaround that uses a thin instrument, conventionally a servery knife, to dislodge the cereal from the exit is awkward, wasteful, and unsanitary, as often the cereal passes over the hand of the user on its way to the bowl. An additional effect is an increase in student stress. Students have been observed using physical blows to the exterior of the cereal dispensers to try to dislodge the cereal. This is significant because, as demonstrated in Bandura's experiments in the 1960s, exposure to just temporary violent stimuli can elevate general levels of violence and aggression, even surpassing the intensity of the initial stimulus. A solution to this problem, therefore, would positively impact not only servery efficiency, but also sanitation, food conservation, and student mental health. An existing alternative would be the purchase of new dispensers, which rely on a different mechanism, such as a paddle-based dispenser. These serveries are not likely to purchase completely new equipment, however, especially considering that the cost of the dispensers of the volume and durability required by Rice range from around $200 to $500. A student-generated solution solving the problem would either eliminate the possibility of obstruction in the first place, or provide a mechanistic way to quickly and easily restore normal flow in such an instance. Some constraints for this device are that it should allow for the easy dislodging of cereal or facilitate steady flow when the dispenser lever is engaged. Other constraints are the cost and simplicity of the solution. A complicated mechanistic fix is unlikely to be accepted and used, and more likely to break. The budget, therefore, should not exceed roughly $20 for the completed solution. The solution should be durable, since thousands of students will be using the device per year. You can be the one who solves this problem for Rice students across campus. Don't let obstructed dispensers be the wrench in the gears that brings Rice dining to its knees. Be the engineer who puts a stop to these stoppages, starting now.